Question 12. A beam of polarized light with an initial intensity I0 passes through a polarizing filter. Initially, the filter's transmission axis is aligned with the polarization direction of the light, so the transmitted intensity is I0. The filter is then rotated by an angle theta from its original position, and the intensity of the transmitted light is reduced to 80% of the original intensity. What is the angle theta through which the polarizing filter has been rotated? This problem tests our understanding of polarized light and how polarizers affect intensity. What do we know? We know that polarized light has its electric field oscillating in a single plane. A polarizing filter only allows the component of the electric field aligned with its transmission axis to pass through, blocking the rest. The relationship between transmitted intensity and the angle of the polarizer is given by Malus's law, which states that the transmitted intensity equals the initial intensity multiplied by the cosine squared of the angle between the light's polarization direction and the filter's axis. Let's get into the solution. Before rotation, the filter's axis is aligned with the light, so all the light passes through. Therefore, the transmitted intensity is I0. After rotating the filter, the transmitted intensity drops to 80% of I0, which is 0.80 I0. Using Malus's law, we write I equals I0 times cos square theta. Dividing both sides by I0 gives I over I0 equals cos square theta. Substituting I equals 0.80 I0 gives 0.80 I0 divided by I0 equals cos square theta. By canceling out I0s, this simplifies to dults ois 0 equals cos square theta. To solve for theta, we take the square root of both sides. Taking the inverse cosine gives theta equals approximately 26 degrees. This is our final answer. What did we do? We substituted the observed intensity reduction to 80% of the initial into the Malus's law formula. We simplified the relation to solve for the angle theta. We find that the polarizing filter was rotated through an angle of about 26 degrees to produce the observed intensity. Theta is measured between the light's polarization direction and the polarizer's transmission axis. Recap. By Malus's law, the transmitted intensity through a polarizer is I equals I0 cos squared theta when theta is measured between the light's polarization direction and the polarizer's transmission axis.